This conference will now be recorded.
Hi Deva. Hi Deva, good evening. Dinesh and Sai Teja, welcome to the session. Okay.
Very good morning, sir.
Okay, good morning. So let's proceed with Kubernetes. As we all know, we are working Kubernetes on Google Cloud Platform. Let's log in. Kubernetes engine, go to clusters. Let's proceed and create a cluster. As we all know, this takes approximately 2-3 minutes time to create a cluster. Meanwhile, quick recap of the concepts what we have discussed in our previous session. Okay, so 25th was our last session. We have learned how to create a pod, isn't it? We have created pod definition file. As we know that the definition file contains three important elements: API version, kind, metadata, and specification. Kind refers to what API version is nothing but the libraries which needs to be downloaded for specific kind. Kind is nothing but you want to create a pod or a namespace or a service, what kind of object you are planning to create. Metadata is providing the name to that kind of object. Specification is all about container information, what the pod should have. So we have seen that examples also, am I right? We have created a pod definition file. So you can see we are creating a pod. Metadata contains information about the name of the pod. Labels can be user defined, isn't it? That container needs to know what is the name of the container and what is the image using which the container needs to be created. So container gets created, and on top of container, first pod gets created. Inside the pod, we'll have a container gets created. So we have experienced how to create a pod. We have discussed few more examples about Postgres pod. We also have discussed about the Jenkins pod, and we also have learned how can we perform port mapping, and we know how to open the ports on the cluster level. So this is what we have discussed in the last session. Today we are moving to the next concept called as a replica set and replication controller. Okay, so this is our plan for our today's session. So I have the notes ready. 28th. Today we'll be discussing about an object called as replication controller. Let's check whether our cluster is getting created. It's the process of creating. Okay. Meanwhile, let us have a discussion about replication controller. We have learned about pod. Now we are learning about replication controller. It's a high level object. Pod is a lowest level of object, isn't it? The minus the smallest component what a Kubernetes can create is a pod. We already have learned that. On top of pod, we have one more component called as replication controller. What does the replication controller do? It's a high level object used for handling multiple replicas of a specific pod. As we have seen in Docker Swarm, we can create multiple replicas of a specific container. Here, instead of container, we refer it to pod. Wherein which, when you create multiple replicas, what do you get? The advantage what you can get is performing load balancing and scaling. So using replication control, pod, we have seen last time only creating a pod. Like how pod can withhold specific load. When the load increases, obviously the pod will be crashed. So what happens? We need to we need to perform load balancing. When you want to perform load balancing, obviously we need to create multiple pods. Those are called as replicas. And perform load balance. We can perform load balancing and scaling. Replication controller, we will be creating anyways the definition file. We have creating a replication controller. Replication controller uses keywords like replicas. It uses keywords called replicas, templates. In the specification section, we'll be seeing that. Replicas refers to how many replicas you want to create. Replicas refers to pod. How many replicas you want to create. Template is nothing but the definition file. What does that each pod contain? So you need to define a template. According to that, multiple pods can be created. In the template section, we can give the metadata related to pods, and also another specification section where we can give the container information. Anyways, we'll experience this soon. So let us work out with the scenario. Yes, the cluster was created. Let's open the terminal. Terminal open. Let's connect to the cluster. Copy the gcloud command. Connected. Let's maximize this terminal. You're connected to cluster. Okay, fine. I want to create a replication controller. Purpose of replication controller to perform load balancing and scaling. I want to create a replication controller with 3 replicas of HTTPD. HTTPD is a web server, isn't it? So I want to create a 3 replicas of HTTPD. Okay. Let's look at the definition file. So the file name can be anything. I'm writing it as replication controller.yaml file. API version, whether it is pod or a replication controller, API version, we should mention it as v1. What kind you want to create? What kind of object you want to create? I don't want to create a pod. I want to create a replication controller. So in the client, in the kind, you should mention the replication controller. When you're creating a replication controller, you need to name that. What is the name of the replication controller? That we mention it in metadata, as we all know. Metadata contains more information about the object you are planning to create. If you're creating a pod, metadata contains the pod name. If you're creating a replication controller, metadata contains the replication controller name. Am I right? So in the metadata, the replication controller, I'm writing it as httpd-rc. That's the name of the replication controller. Okay, so let's have a naming convention that every replication controller ending with RC. You can have any name. You can write your name also. No problem. Labels are user defined, as we know, or I'm writing it as Durgasoft. This is information about replication controller. In the specification, can you see bottom specification? How many replicas you want? Using the replicas keyword, we will mention how many replicas you want. I want to create 3 replicas. 3 replicas of what? That you should define it in the template. Can you see? In the specification section, we have a template. In the template section, you come into technicalities, metadata. What is the name of the pod? HTTP-pod is the name of the pod. Label. Author, I'm writing it as Durgasoft. And pod will have what? This is pod. Pod in the specification section contains what? Specification section contains container information. What is the name of the container? My HTTPD image. Which container needs to be created using image? What is the name of the image? HTTPD. Port HTTP default port, it's 80, and the host port I'm mapping it to 8080. That's it. This is the template. Using this template, three pods will be created, and these 3 pods will be created under the replication controller. Clear about this. So replication controller is a high level object, 1 level over the pod. Containers. As we all know, you will have a pod. Inside the pod, you'll have a container and multiple pods. We can group it under replication controller for load balancing. Am I right? So let's do this. You can have any name. I'm writing it as replication controller. 11.yaml file. We have created directory. VIM replication controller.yaml file. Insert mode. This is the replication controller definition file. Escape. To save and quit. We are done with creating a definition. We have not executed. We have definition. Our definition is ready. Replication controller definition is ready. Next point. Do we have any pods as of now? We know the command kubectl get pods to see the current pods, whatever we have. We have no pods. I think so, because the new cluster which we have created, there are no pods. Fine. Shall we run this replication controller file? And you need to open the host port 8080. I already have done that. I don't need to do it again. I'm running the replication controller. What's the name of the replication controller? Replication controller 11.yaml file, isn't it? When you do this, what will happen? The replication controller gets created. Replication controller gets created. In the replication controller, how many pods we have? 3 pods. Now kubectl get pods, as we have mentioned in the definition file, that we need 3 replicas. As you know, we need 3 replicas. So when if you want to now try for the pods, how many pods we are having? Pod 1, pod 2, pod 3. How many pods we are having? 3 pods. Did we create the 3 pods individually by creating 3 definition files? No. We have created a high level object called as replication controller. On top of that, under that, pods are created. You want to know which pod is running in which node? We have a cluster of 3 nodes. Which pod is running on which node? kubectl get pods wide output will provide you the wide nodes information. One pod is running on a node which is ending with 0jvs8. Oh yes, fine. Now can I access this HTTPD? Take any external IP. You can take this one or any external IP. So how can we get the external IP? Get nodes, get pods, get nodes. We'll get the external IP. So I'll take the first external IP, and then HTTP is running on what port number? We have mapped the default port is 80, and I have mapped it to 8080, isn't it? So let us access it from the outside network. Yes, it works. This is HTTPD web server output, default output. Okay, so we have created replication controller. We have created a replication controller. But now, how to delete the pods? These are all the pods specific to a replication controller, and the name of the definition file is replication controller 11.yaml file. Am I right? I want to delete this replication controller. What will happen when you delete the replication controller? The corresponding pods related to this definition will also be removed. Fine. This is about replication controller. Next level object, which helps in performing load balancing, auto scaling. But the replication controller object, what we have discussed now, is deprecated. Deprecated is nothing but it's outdated. Similar to replication controller, we have one more component called replication set. Anyways, replication control is still used, but we have one more object Kubernetes has done created that is called as replication set. Pod is the smallest Kubernetes object. We have learned it. Next level is replication controller. We have just seen it. Replication set is similar to replication controller. The advantage of replication set. So nowadays, whatever the replication controller can do can also be done in replication set. And replication set is having a specific advantage. We'll see that specific advantage. Replication set, in replication set, we are anyway seeing the replication set example now. In the replication set, we have an additional field in the specification section called selector field. The selector field uses a child element called as match labels. We have a field called a selector field. Selector field is having a child element called match labels, where it will search for the pods based on specific label and add them to the cluster. We'll see this practically. Let's say if a pod is creating, you can make that pod as part of replication set by using the match labels. We'll see now. Okay, look at this. Create a replication set. Start with 4 Tomcat replicas. Like in a previous example, we have created 3 replicas of HTTPD. I want to create 4 replicas of Tomcat and then perform scaling. You should be able to do scaling, right? Let's do it. File name can be anything. Replication set 11.yaml file is the name of the file which I want to create. For replication set, for rest of all the API versions, we are writing it as V1, isn't it? As of now, all the API versions we have used for replication set, we should write apps/v1. What kind of object you're creating? You're creating a replication set. Metadata, name of the replication set you're planning to create. I want to create the replication set with the RS. As this replication set contains Tomcat pods, I'm rating it as Tomcat-RS. Labels can be anything, or what type of component is a web server, or the Durgasoft. Labels can be anything, both key and value pairs or anything. Spec section. In the replication controller also, we have specs. We have mentioned replication as 3. Here we mentioned replication as 4. Then comes the selector field. Then comes the specification section. So replicas 4, selector field. Look at this, as I told you. In replica set, we have in the specification section, we have a selector field. Look at this, selector field is part of specification section. Selector field uses a child element called match labels. Yes, we are using match labels. In the match labels, I'm mentioning it as type as web server. If there is any pod, if there is any individual pod whose label is web server, who in the label whose type as mentioned as web server, if that pod is running, that will pull under this replica set. So it will be considered as one replica instead of creating new replicas. So that's the selector field. Okay, type as web server. In the template, you need to provide the actual specification. Metadata, Tomcat pod, type, label, type it as web server, specification, name of the container, my web server, image Tomcat, Tomcat runs on 8080, mapping it to 90904. So what the replication controller will do, the same thing can also be done by the replication set. Okay. So I am creating a replication set. The name of the replication set is replication-set11.yaml file. Save and quit. Replication-set11. Replication set has been created. Replication set has been created. Replication set is having how many replicas? 4 replicas. So if you want to know the information, get pods. 4 replicas, we should get 4 pods, right? Look at this. 4 pods. Pod 1, pod 2, pod 3, pod 4. 4 replicas. kubectl get replica set will get information about the replica set. We have only one replica set. Tomcat rs. Desired count is 4. Current count is 4. Ready is 3. 1 is still pending. That's the reason ready is 3. So this is the command. Get pods will get the information of pods. Get nodes will get the information of nodes. Get a replica set will get the information about replica set. Create. Now let's perform scaling. Replication set helps in scaling of containers, isn't it? Scaling of pods. Right now, how many pods we are having? Right now we are having 4 pods. I want to increase from 4 to 6. In 2 ways we can perform scaling. In 2 ways we can perform scaling. One way, open the definition file, that is the code which we have written. Make changes in the code. Where we should make changes, obviously in the replicas. Instead of 4, you need to write it as 6. Make changes in the, we are not changing the file name. File name is the same. We are making changes in the code. Okay, replica set 11, right? And then kubectl, we should not use create because it's already created. We should use replace -f replica set 11.yaml file. This is one way. What we need to do, making changes in the definition file, and kubectl replace command needs to run it so that the new code gets executed, and then instead of 4 replicas, 6 replicas come into action. So let's do that part. Opening the YAML file, that is nothing but definition file. I go to insert mode. I go to the appropriate field. What field? Replicas field. Instead of 4, I'm writing it as 6. Escape :WQ to save and quit. Replace. Let's do that. Done. Replica set has been replaced. Replica set is replaced. Get pods. Should get the current pods. 6. Getting 6 pods. You have successfully scaled up the number of replicas. This is option 1, making changes in the code level. Option 2, we can do it by using the command. What is the replication set you need to use? Replication set 11.yaml file. Kubescale is a command. -- replicas is a keyword, you know, replicas is a keyword. You want to scale down. It can be, this command is used for both scaling up as well as scaling down. Right, first we have started with 4. First we have started with 4 replicas. Next we have replaced the definition file and we have increased the number of replicas to 6. We have scaled down to 2. Now we are scaling down to 2. Let's see. Scaled. Now kubectl get pods. How many pods we should get? 2 pods. Are we performing scaling of containers? Am I right? Are we performing scaling of containers? Yes. Okay. So this is about the next concept called as replication set. This is about replication set. We have learned how to perform scaling, scale up and scale down. I want to discuss one more component. A service object. First we have learned pod, next we have learned replica set, and we are learning service object. This is used for performing network load balancing and performing port mapping. It's used for performing network load balancing. At network level, the load should be distributed. Replica set does not help in performing network load balance. It just creates number of pods, but the balancing should be done by using a service object. So one more high level object we are learning a service object. Service object uses 3 ports. Service object component or on service object uses 3 ports: target port, host port. Target port is the actual container port. For example, for Tomcat 8080 is the actual container port, right? The default port. That's the target port. Port refers to the port at service object level. We'll see that practically. Host refers to the host machine port which needs to be accessed from the external network. We'll see this practically. Okay. Service objects are classified into 3 types. Service object is divided into 3 types. You can create 3 types of service objects: cluster IP, node port, load balancer. Cluster IP, node port. You can create a service object of type cluster IP. We can create a service object of type node port. We can create a service object of type load balancer. This is the default type of service object. Which one? Cluster IP. The default type of service object used in Kubernetes. And this cluster IP service object gets created and is used when we want the pods in the cluster to communicate with each other, not the external network. Okay. Now, when should we create a cluster IP? When you want the pods needs to be communicated within the network, not from when it should not be accessed outside the network, then we go for cluster IP. So when you create a pods inside the service object, we'll see this, that pod cannot be accessed externally. For example, you have created a MySQL pod and WordPress pod. So MySQL WordPress pod communicate each other, but they cannot be accessed outside. That's the concept of cluster IP. Node port, service object of type node port, is used when we want to access the pods from the external network. Obviously, we want to access the pods from the external network. In that case, we need to create node port. It also performs network load balancing. Even if the pod is running on a specific slave, we can access it from another slave in a cluster. We'll see this practically. If a pod is running in a slave is nothing but different node, we can access it from a node in the cluster, from the other node of a cluster, because it is completely external. We'll see this practically. Load balancer. One more service object of type load balancer. It is similar to node port. Load balancer is also similar to node port, used for external connectivity of the pod, also performs network load balancing, and assigns an additional thing. What it does, it assigns a public IP to all the nodes combined together. We have 3 nodes. Let's say one node is having one IP address. One node is having one more IP address. Third node is having one more IP address. Every node will have an IP address. Load balancer assigns one more IP, a common IP. In combining all these 3 IP, this gives one more IP. Okay. So if I want to access a pod inside this particular node, I don't need to use this IP. I can use the common IP. Okay. So it is similar to node port used for external connectivity and also perform network load balancing. It assigns a public IP for all the nodes combined together. All this, we'll see it now. Please have a look at it. We have a pod definition 11.yaml file. Do you remember? Pod definition 1.yaml file, not 11, 1.yaml file. We have seen this in a previous class. In the pod definition 1.yaml file, as you know, pod will be created in this command. You want to see the YAML file? Look at this. This is the pod definition YAML file. What I'm doing, creating a pod, name of the pod Nginx pod, for a container. App server is the name of the container for Nginx image. So pod gets created. Okay. First, what I'm doing, I'm creating a pod using the definition file. Okay, so pod gets created. Fine. Important is that, are we creating any service object? Try to understand. Are we creating any service object in this definition file? We are not creating any service object. But along with the pod, the service object is also gets created. Service object gets created. And there are 3 types of service objects as per the definition I have given you. There are 3 types of service objects. Cluster service object of type cluster IP, node port, and load balancer. Okay, fine. As I told you, service object gets created. Let's experience that first. So if you want to see the code, VIM, I am opening the pod definition 1.yaml file. Same code what I have shown you. Nginx container present in the Nginx pod. Creating the pod. Pod gets created. Along with the pod, service object gets created. How to see the pods? kubectl get pods. Nginx pod got created. And along with it, service gets created. How to see the services? kubectl get all. We'll get all the components. A service object got created. A service object got created of type what? Cluster IP. a service object got created of type cluster IP. Hence, we cannot access this outside the network. This, even though it's an Nginx pod, you cannot access it outside the network. So what we will do to access it outside the network, we'll be creating a service object. To create a service object, I am creating a file called a service1.yaml file. We are creating a service object for this pod. We'll create a service object for this particular pod. Kind. We have learned kind as pod. We have learned kind as replication controller, kind as replication set. Now I'm creating kind of service. What's the name of the service? Nginx service. Labels can be specification. What type of service object I'm creating? There are three types of service object. I'm creating a service object of type node port. Here you can see in the kind section we are specifying what kind of service object we are creating. Node port. Ports. Target. Nginx runs on 80 port number. That's the default port of Nginx content. This is service object port. It can be same or different. I'm maintaining the same port. Node port is at the host level. At the cluster level, how we are planning to access it. That's 30,008. Using the selector field, where you are mentioning that you are creating a service object of this particular pod. Okay, in this particular selector field, what I'm using, author equal to Durgasoft, type equal to reverse proxy. It checks for all the pods. It checks for all the pods whose author equal to Durgasoft and type equal to reverse proxy. Is there any pod with author equal to Durgasoft and type equal to reverse proxy? Yes, we have it. So this for the use, so it identifies that for all that particular pod, service object gets created. So I'm creating a service object. I'm naming it as service object 11.yaml file. Accessing the service object. Running the service, service object 11.yaml file. kubectl service object got created. Now the Nginx pod should be able to access external. How many nodes we shall have? As we have 3 nodes, take any, as we have created a node port, we can access it from any node. For example, I'm taking this particular node and I'm accessing using 30,008. That's the port which we have opened at a service object level, right? Let's see that. Yes, welcome to Nginx. So what we have done, service object is used for accessing, the right way of accessing the pods to the external level happens using the service object. The right way of accessing the pods from the external network is done by using the service object. using the service object. Service object is of 3 types: cluster IP, node IP, load balancer. When you create when you create a pod, service object is created of type cluster IP. It cannot be accessed outside. So I have specifically created a service object of type node IP, and then using that service object, what fields? Selector field. I've selected the pods which I want to access externally, and then I have defined the service object. So the purpose of the service object used for performing network load balancing. At network level, load balancing happens and performs port mapping. So we have created service object for performing network load. Now network load balancing happens, and I have selected any node at the network level. As load balancing happens, I have selected any node. I have not checked whether pod is running in which node or not. I have selected any node and I am accessing the pod. Clear? This is about the service object. Clear about this? So we have learned 3 more components. Replication controller. What replication controller does, it also be done by the using replication set. So we have also seen replication set. The advantages, we have selector field in the replication set. We also have discussed about one more component called as service object. So this is what we have planned for today's session. Tomorrow I'll show you a simple project scenario, how exactly Kubernetes helps in maintaining an application. Okay, maintaining an application. I will be explaining you one voting app which is handled using Kubernetes. That's pretty popular example. Anyways, we'll be discussing this. You'll understand in what cases we need to create a service object of type node, what type we should discuss about service object of type cluster. So all this we'll understand it when you look at the project book. Okay, so please practice this. This is what I have planned for today's session. Any questions, Deba, Dinesh, Saitej, Taruni?
Nothing, sir.
Okay, are you able to get the videos?
Yes, sir. Yes, sir.
Okay, thank you. And this notes I'll send you immediately. Thank you all.